Hello. So we're going to be talking about additional loop controls for both for loop and while loop. So, okay. Now, if we look at the guessing game that we wrote last time, one of the things that you might notice is we have this correct variable, which kind of represent if the user get guess the secret correctly or not. It's used in three different places, right? And its whole purpose is so that we can get out of the loop when the user gets the secret. And there is really only one place where the user gets the secret, and that's really in this one place. And this is the one place that we want to terminate the loop. But we have to use this variable in three different places. So there just seem to be gotta be an easier way to do it. Okay. Yeah. Again, if you want to look at the code, the complete code is this. And by the way, um, I hope you noticed by now that if you like click on a variable, the where the variable is used is all highlighted. Okay. So when I click on correct, you can see correct, correct, and correct 3 times. So that's where that variable is used. So it's very useful at a glance to see where your variables are used. Anyway, sorry for the digression. So um, what's a simpler way to write this loop? Well, there is this one keyword called the break. The break keyword, what it does is that it immediately terminates a for loop or a while loop. Okay, immediately terminates it. So let's see an example of that. I'm going to show an example. This is an example. So I have a list here. I call it numbers, although they're really not numbers. So they're just a few items. Each one of them is a string. Now these strings, some of them are numbers, right? 30, 34, the string. 34 is a number. 1 is a number. This is not a number. Right? 2 is a number, even though again it's a string. It's a number in a string. And then this is yet not a number. Right. So what we want to do is okay. We want to detect which string is a number and which is not. Now I know we've been kind of avoiding that up to this point, and there's good reason for that, because the proper way of detecting whether a string is a number, it requires the understanding of exception. However, there is there is a kind of a way to do it without understanding exception, although it's not really the right way. And but anyway, let's try to use it. It's called so the number is an item in numbers, right? And each item is a string. So we can check if that string contains all digits. Okay, and that's by using the dot is digit method on the string. Now, the reason I say this is really not the right way to do it is because a string, oh, sorry, is digit, it cannot handle a negative number. It cannot handle floating point numbers. Okay, it really check like digits 0 through 9. So any negative with a negative sign, any floating point, it wouldn't recognize those as digits. So this is not really not the right way to check if a string is a number, but for now, it works for our demonstration purpose. It works. So anyway, so what this loop does is that, excuse me, it checks all the, for each item in the list, if that item is not a number, then we say we found some non-number string, and we print that thing out. And then as soon as we find one, we break. And then after the loop, we say we're done, right? So when you run this, then here, it tells us it found non-number string, which is this string, which is, oops, this one, okay? Now, as soon as it prints this message, it breaks, which means it terminates the loop. So even though there is another item here later, that is, again, a string that is not a number, we don't go there because the break here terminates the loop, terminates the for loop. Okay? What if I will remove break? Well, pause for a moment, think about what happens if I remove the break. Well, it should be fairly obvious. If I remove the break, after it finds the first one, it will keep going to the next item in the loop and then in the sequence or in the list and next item until we finish all the items, right? So you would expect it to find all the non-number strings in this list. And it did. It found 2. All right, that's what this slide says. Now, so how does break help with simplifying the code that we wrote for the guessing game? So let's come back here. Flow control, sorry. Okay. So, well, what we can do is as soon as the user got the secret correct, we can break, right? Okay, well, if that were the case, we really no longer need a condition to terminate the loop, right? So we can just say, okay, we'll repeat this forever. And when the user guessed it, we break out of the loop. So it's really not a forever loop, but if you just look at the loop control, it looks like it's an infinite loop, but it's not because we do break out of it when we guess the secret. And then now we got rid of the 2 places where we set the correct variable and use the correct variable. Well, we really don't need this thing anymore. So there, gone. Well, let's see if it still works. So what's my guess? I say 1, 200,000. Okay, wait, 1,000. And then let me try to guess that it's correct. There, 123. We got it. We come in here and then we break. So that terminates the loop. Okay, so this piece of code, I would say it's simpler than what it was before. So that's what this slide says. And okay, so that's all I want to say for break. So we want to move on. We want to introduce actually yet another loop control. And to motivate for that, let's actually try to make the guess game a little more robust by making sure that what the user types in is a number. So as we just saw in the example for break, that we can use the is digit to check if whatever the user type is a number, even though it doesn't detect negative numbers correctly, but it's fine for now. And it's really better than not checking at all, right? So what we can do is here. So before we convert it to a string to integer, let's actually check it first. So I'm going to create a new variable. I'm going to call it the guess string. It's no longer just a number, right? So, and I'm going to say if the string is is a digit, I would tell the user, please enter number only. Okay, and then if that were the case, I really do not want to well, we cannot compare the number to whatever the user type to a number, right? Which is the secret. The secret is a number. So we really don't want to do this. So that means I'm going to say else. I only do this if what the user type. Oh, wait, sorry. No. So if it's not a digit, we tell the user, hey, type a number. Otherwise, we will convert the string into a number and do our normal thing. Okay. Okay, let me make sure it works. So I'm going to try ABC. Okay, so it tells me, hey, enter a number only. All right. So now if I, enter 1, it is doing the right thing now. So it says too small. What you guess? I'm going to say 1, 2, 3. Excuse me. It get it right. Okay. And that's what this thing does. However, one thing you notice that, or you might have noticed that what I have to do was previously this block of code, well, it's considered what's the normal execution path, right? Because it does the real work that we care about, right? This normal execution path is now indented under a else clause. And as a matter of fact, it's at the same indentation level as this error handling path. So error handling path, normal path, when they are at the same indentation level, it's generally considered not a very good style because it seems like, we care about both equally as much, whereas we really care about mostly the normal execution path, right? The error handling is kind of like it's a necessary evil. Hopefully we'll never get into here, but if we do, then we get into here. So what we really want to do is, or what we really want is, when the string is not digits, we just want to skip this. Okay, and there is something in Python that allows us to skip the rest of the current iteration, and that is the continue keyword. Okay, so what it does is it skips the rest of the current iteration. It checks the condition of the while loop. Well, in a for loop, it tries to get the next item from the sequence, right? Either one. So if those conditions are all fine, then it will just continue to execute the next iteration. So let's actually work on an example. And I know we've done this many times already. Here's an example of how to print even numbers. So I'm going to do for I in range, let's say 20. Okay, I'm trying to just print the even numbers. So if I modulo 2, if it is odd, I will skip printing it. Otherwise, I'll print it. Okay, so if I run this, and there again, I print all the even numbers up to but not including 20. So again, look at how this works. When I is 1, okay, when I is 1, I modulo 1 modulo 2 is 1. So it continues, meaning it will skip whatever's after it inside the loop, and we will go to the next iteration of the loop, which is I equal to 2. And when we come here, 2 modulo 2, that is 0, so 0 does not equal to 1. It will skip the continue statement, but instead it will print 2. So that's how 2 got printed and 4 get printed and so on. So that's how continue works. Continue just skips the rest of the code inside the loop, but it will continue to the next iteration of the loop. Okay, so how does it help to fix the style problem I just mentioned? Well, if we come back here, if it's not a digit, if it's not a number, we tell the user and we say continue. Oops, sorry, little Java just slipped in. So we continue when the number is, when the string is not a number, which means we don't have to put the normal path inside the else. Okay, I just reduce one level of indentation. So again, look at this. If the get string, if what the user type is not a number, we skip doing this and we go back to the beginning and ask the user to type in the guess again. Okay, so let's run this. What's my guess? I'm going to say ABC, and it works as before. We detect that it's not a number, and we skip checking the guess, and we ask the user to type the guess again. Okay, and if I say 1, it's too small, say 1, 2, 3, now we got it. Okay, so there, in one game, we use both continue and break for different purposes, obviously, to control how this loop works depending on what the user types. Okay, so there it is. And like I mentioned, now the normal path of execution is not indented. It's back to where it was before, which is a more readable place for the normal path of execution. So maybe your question, maybe not. So all that is just so that we can have one less level of indentation. I mean, it doesn't look that bad. Well, proper indentation is actually very, very important for readability. And to illustrate that point, I'm going to ask you to actually try to write the code for this little problem here. So this little problem would be, you just repeatedly ask the user for 2 numbers, and then just add them up and print their sum. Now, for any of these 2 numbers, if the user enters something other than a number, again, just use the string.isDigit function to check it. If the user enters something other than a number, tell the user, and then you start from the beginning again, right? So even if the user already entered the first number, but then the second thing is not a number, you start from the beginning to ask the first number again. Okay, so you should write that. You should be able to write the code without continue. So do that first. Okay, and then try to write the same code, but with continue. And then you can compare and contrast the two approaches. So go ahead, pause the video, give this little problem a try. Okay, assuming that you have tried it, this is the solution that I come up with. So very simply, if we ask the user to enter the first number, if the first number is not a digit, we say, hey, that's a bad number. Otherwise, okay, we ask the user to enter the second number. And then if the second number is not a digit, we say bad number. Otherwise, now we really get to the real work, which is adding number 1 and number 2 together and print it out. As you can kind of see here, by the time that we get to do the real fun work, the normal path of execution, we are at 3 levels of indentation without using continue. Okay, now hopefully you agree with me. This is less readable, less kind of not the best style. Just again, because the real work is deeply indented. Okay, so if you haven't already done so, now try to convert this piece of code or try to write your own code now using continue. Okay, assuming you've done that, here is my version that that use continue. Okay, so the way this works, very similar to before. Enter the first number. Now, if it's not a digit, we tell the user and then we continue, which means we skip everything from that point on and go back and ask for the first number again. And then if that number is a digit, well, we move on to ask for the second number. And the second number, if it's not a digit, we continue, meaning skip the rest of the things again, and we go back to the beginning to ask for the first number. And then if the second number is a digit, then we can finally add them together and tell the user the sum. And if you look at the end, which is when we actually add the two numbers together, that's what we care about, right? That's what this program is about. That's really just at one level of indentation. And to me, and I think many Python programmers would agree, this is a more readable version of the code. Again, thanks to the use of continue. Okay, hopefully that makes sense. Now, there's actually one more loop control that is kind of special to Python. So the for loop and the while loop, you can actually have an else clause after them. It is not as intuitive as the if else or the else in the if else case. But they do have their uses, that's why they're there, but they're really not strictly necessary. And for those of you who actually know other languages such as C++ or Java, they don't have an else clause for the for loop and the while loop. So that's why it's really not strictly necessary. So for now, I would like you to focus on understanding how the for, while with the break and continue work. And only if you completely understand those, then you might try to understand the else clause. I think it's described in Professor Losev's reading material. So that's optional, but you're welcome to read about it and even use it in the assignments if you find them appropriate. But again, it's optional. Okay, I think that's the end of what I want to say for loop control.